Hello everyone, this is the Cambridge IGCSE Mathematics paper 4-3 written in May-June 2025. There are 26 questions in this paper. If you are seeing this channel for the first time, please kindly subscribe to my YouTube channel by clicking the subscribe button. Also, hit the notification bell to receive notification anytime I upload new videos. Don't forget to like, comment and share this video. So this is a list of formulas that can help you while solving the questions. So let's jump into the first question. Find the median of these numbers. Okay, the numbers are already arranged in ascending order. Okay, so we need to divide them into two groups. Okay, so if you do that, these two numbers fall at the middle. Okay, so we need to find the midpoint of these two numbers, that is 11 and 13. So the midpoint will be 12. So the median of these numbers is 12. Question 2. In triangle ABC, AC is equal to 21 meters and BC is equal to 15.9 meters. Using a ruler and compasses only, complete. Question 2. In triangle ABC, AC equal to 21 meters and BC equals 15.9 meters. Using a ruler and compasses only, complete the scale drawing of the triangle. Use a scale of 1 centimeter to represent 3 meters. The side AB is drawn for you. Okay, so this is side AB and we have to use the scale 1 centimeters to 3 meters. So we can actually do something here. So if you write centimeters ratio meters, so we have it to be 1 to 3. Okay, so let's go to the given sides. We have the length of AC to be 21. So what will be the value on paper? So if you have 21, okay, so what was done to 3 to get 21? That is by 7. So you can do by 7 here. Okay, so that will be 7 centimeters. So that means 21 meters will be 7 centimeters on paper. So we have to do the same thing for the length BC. Okay, so BC is 15.9 meters. So you can also do 15.9 here. Okay, so what was done to 3 to become 15.9 meters? Okay, so it is multiplied. Okay, multiplied by 15.9 divided by 3. So you do the same thing here. Okay, so 15.9. Question 2. In triangle ABC, AC is equal to 21 meters and BC equals to 15.9 meters. Using a ruler and compasses only, complete the scale drawing of the triangle. Use a scale of 1 centimeter to represent 3 meters. The side AB is drawn for you. So let's scroll down. So this is side AB. So we need to convert 21 meters to centimeters as well as BC, which is 15.9 meters. So from the given scale, so we know that we can actually write centimeters ratio meters, and we are told that 1 centimeter represents 3 meters. So if you have the length AC to be 21 meters, so that will be 21 here. So what's done to 3, okay, to get 21? So that is multiplied by 3. So you need to do the same thing here, multiply by 7 rather. So you also multiply by 7 here. So that will be 7 centimeters. So the length AC, which is 21 meters, will be 7 centimeters on paper. So we can do the same thing for length BC. So we know we have 1 to ratio 1 to 3, then if you have 15.9 here, so that means this was multiplied by 15.9 divided by 3. So you need to do the same thing here, 15.9 divided by 3. So the length of BC will be 5.3 centimeters. So the next thing you need to do is to pick a pair of compasses, okay, and draw the length AC and BC respectively. I have a ruler and a pair of compasses, so I need to measure the length AC, which is 7 centimeters. Okay, so from here, so I need to adjust this to 7 centimeters. Okay, then I'll need to go to the base where we have the length, the line segment AB. Okay, so this is AC, so the center at point A. Then I need to draw an arc. Okay, so let's draw it from here. Then we go back to the second one, which is the length BC. So length BC is 5.3 centimeters. So let's measure 5.3 centimeters from here. Okay, so place the pair of compasses on the ruler again, center at 0. Then let's measure 5.3 rather. Okay, so I think I need to take this down a little bit. Okay, 0.0 here, then 5.3 will be here. Okay, good. So I'll go to the base again, center at B now. Okay, so we need to intersect this line. Okay, wow, so this is a little bit short. Then that means I have to redraw the line AC again. I need to take it again, so because it should intersect with this. So let's measure so I think I can actually remove this. Okay, so I'll take the line AC again. Okay, so that should be 7 centimeters. So let's place a pair of compasses there once again. So let's measure 7 centimeters. Stretch it a little bit. Okay, so this is cool now. So let's take this and intersect this curve. So center at A. Okay, then we need to intersect this. So this will be the point C. Okay, where the intersection of the two curves will be the point C. So we can actually join them together. So take this one like this. Okay, and do this. So that is how to complete that. Okay, so now let's go to the next question. That is question 3. From this list, write down a natural number. So a natural number is a counting number. Okay, so we have 23. So you can write 23 here. So you could as well write square root of 144. Okay, 144 is equal to 12. So you can write 23 or square root of 144. So part B, an irrational number. An irrational number is a number that could be written as a numerator over as a fraction, that is a numerator over denominator. So if you look at this here, question 3. From this list, write down a natural number. A natural number is a counting number. So 23 is an option. Okay, you could as well write square root of 124 because square root of 144 is equal to 12. So you can write square root of 144 as a natural number. Then part B, an irrational number. An irrational number here will be root 15. So an irrational number is a number that cannot be written as a fraction. So that is an irrational number. Okay, so let's go to the next question. That will be question 4. The diagram shows a pentagon made from two congruent trapeziums. The area of the pentagon is 130.2 squared centimeters. Calculate the value of x. Okay, so since we are given the area of the pentagon, so one thing you should take note is that the area of the pentagon is the sum of the area of the two trapeziums. So we can actually add them together. The area of one trapezium is the addition of the two parallel sides, okay, that is x plus 11.4. So that will be x plus 11.4. So this is the addition of the two parallel sides, okay. Then multiply by the height. So the height now is going to be 7. That is from here to this point. That is 7. Okay, since they are congruent, they will be equal. So multiply by 7, then divided by 2. So this is the area of one trapezium. Okay, so now if you multiply the whole of this by 2, so this will be the area of the two trapeziums. So which is equal to the area of the pentagon. So 130.2 squared centimeters. So we can easily calculate the value of x here. So from here, so we can say this will cancel this. So we are left with, let's write here, x plus 11.4 into 7 equals to 130.2. So if we expand this bracket, so better still, you can divide both sides by 7. I think that will be easier. So this we cancel out this. So we are left with x plus 11.4 equals the division of this 130.2 divided by 7 gives 18.6. So subtract 11 from both sides. So x, the value of x equals 7.2. So this will be 7.2. So let's go to the next question. Question 5a. Convert 780 square centimeters into meters. Okay, so we can use an acronym, that is King Henry died by drinking chocolate milk. Okay, so this is the base where we have the liters, the grams, and the meters. Okay, so we want to convert centimeters to meters now. So centimeter squared to meter squared. So this is centimeter and this is meter here. So you move from this to this place, 1 and 2. You move twice in this direction. So that is for centimeters to meters. So that is 2 steps. So for centimeter squared to meter squared, it will be double, times 2. Okay, so that will be 2 steps times 2. That will be 4 steps altogether. So what we're gonna do now is to write 780 here. Then from here we move 4 times in this direction, 1, 2, 3, and 4. So the point's gonna be here, so we need to fill up this with 0. So the final answer will be 0.078, okay, 0, and you can write it like this better. Okay, part B, convert 0.037 meter cube into centimeters cube. So we're going to use the same acronym. Okay, King Henry died by drinking chocolate milk. Okay, so this is where you have the base. This is the base where you have the meters, you have the liters, and you have the grams. Okay, so now we want to convert from meters to centimeters. That means we need to move from here, 1 and 2. You move towards this direction. This is 2 times. Okay, now we are dealing with meter cube. So we're gonna multiply the two steps by 3. Okay, so that will be 6. That will be 6 steps altogether. So from this, okay, I think I can write this here again. 0.037. So let's move from the decimal point here and count and move 6 times. 1, 2, 3, 4, 5, and 6. So the decimal point is gonna be here. So let's fill up this with zeros. 1, 2, and 3. So this will be 37000. So that is 37,000. So that will be the conversion. So question 6. One titanium atom has a mass of 7.95 times 10 to the power of negative 23 grams. Calculate the number of titanium atoms in 1 kilogram of titanium. Give your answer in standard form. Okay, so what you can do, if one atom implies 7.95 times 10 to the power of negative 23, okay, then n number implies 1 kilogram. So that is 1 kilogram, which is equivalent to 1000 grams. Okay, so we're gonna cross multiply. Okay, so and n will be equal to 1000 grams over 7.95 times 10 to the power of negative 23. Okay, so this, you can input this into your calculator, or better still, you can write 10 to the power of 3 over 7.95, okay, times 10 to the power of negative 3. So you can still input it into the calculator like this, or from here straight away. So the value of n will be equal to this 1.26 times 10. Actually, this is what calculator will give you. 0.1258 times 10 to the power of 26. Okay, but this is not in standard form. Okay, so you have to rewrite this. Okay, and that will be, so we need to shift it, because the standard form number must be between 1 and 10. Must be greater than or equals to 1 but less than 10. So this is 0.1, which is less than 1. So we have to write it. That means we need to shift this decimal point by 1. So if we shift the decimal point by 1, okay, so you're gonna drop this. Okay, this is gonna drop by 1. Okay, that is the power of 26 will drop by 1. It will become 25. So that will be 1.25 times 10 to the power of 25. So this is the final answer. 1.25 times 10 to the power of 1.2, I think, oh sorry, this should be 1.26, approximately 1.26. So let's write this again. So this will be 1.26 times 10 to the power of 25. So let's go to the next question. That should be question 7. We are given the universal set, okay, which is x, such that x is an integer and 1 is less than or equals to x, where x is less than or equals to 12, okay, and x is less than or equals to 12. Okay, set E, okay, is a set of even numbers, while set M is a set of multiples of 3. So we need to write this. So set E, okay, will be equal to 2, 4, 6, 8, 10, and 12. Then set M will be multiples of 3. That will be 3 times 1, 3, 3 times 2, 6, 3 times 3, 9, 3 times 4, 12. Okay, so these are sets E and M respectively. Okay, so now to get the number of elements in set M, that's the cardinality. So we have 1, 2, 3, 4. So we have 4 elements or 4 members in set M. Part B, write down the set E intersection M. Okay, so the common elements. So if you observe, if you look carefully, you see that we have 6 and 12. So you have 6, 12 here. So part C, Y is a member of union, the complement of E union M. So write down a possible value of M. So the first thing we need to do is to get the complement of E union M. Okay, so to do that, so let's firstly get the union of E and M. So this will be set of we need to combine the two sets, set E and set M. So we combine them together. So this will give us 2, 3, 4, 6, 8, 9, 10, and 12. Okay, so now we need to get the complement of E union M. So the complement of E union M is the set of numbers, okay, that are available in the universal set but not in this union. Okay, so that will be, so don't forget that the universal set is from 1 to 12. Okay, so we want to pick the numbers from 1 to 12 that are not in this union E union M. So that will be 1 is not here, 5 is not here, 7, 11. Okay, I think that's all. Okay, now so Y is a member of this set. Okay, so we just have to pick any number from these. Okay, so that is Y could be 1 or 5 or 7 or 11. So I'll pick the first one.
Question 8. Factorize 28xy minus 12x. So here we can factor out 4x. So if you factor out 4x, you have 4x into 7y minus 3. So this will be our final answer. 4x into 7y minus 3. Let's go to part B. Y minus 6x plus 2xy minus 3. So here we can actually rearrange this to be y minus 3 plus 2xy minus 6x. Then from here we can factor out 1. Then from here we can factor out 2x. So that will be 1 into y minus 3, then plus 2x into y minus 3. So the final answer will be 1 plus 2x into y minus 3. So 1 plus 2x. So let's take that again. So this will be 1 plus 2x into y minus 3. So let's go to the next question. That will be question 9. Simplify this. So we need to multiply the numbers. That will be 7 times 5. That will be 35. Then x to the power of 5 times x to the power of 3. So we apply multiplication law of indices here. So we pick one of the bases, which is x. Then we add the powers. 5 add 3. That will be 8. Then y to the power of 1 multiplied by y to the power of 2. So we also apply multiplication law of indices as well. That will be y to the power of 1 add 2. Okay, so that will be 3. So the final answer here will be 35x to the power of 8, then y to the power of 3. Then part B, 7 to the power of n equals 50 root of 7. Okay, so we can rewrite this to be 7 to the power of n equals 7 to the power of 1 over 5. Okay, so 7 cancels 7 because they have the same base. Then n equals 1 over 5. Question 10. Expand and simplify this. Okay, so we need to expand the bracket. That will be 2x, then minus x times 5. That is minus 5x. Then minus x times minus x squared. That will be plus x cubed. Okay, so we can simplify this to be minus 3x plus x cube, so which is the same as x cubed minus 3x. So let's write x cubed minus 3x. Then part B, x plus 4 into this into x plus 3. So we need to expand this. So let's do this 2. So this 2 will give us x times x. That will be x squared minus x times 5, 5x. then plus 4 times x, that is plus 4x, plus 4 times minus 5, that will be minus 20, okay, into x plus 3. Okay, so we can actually simplify these two. This will be x squared minus x, then minus 20, okay, into x plus 3. So we can now expand this again, okay, by multiplying x by the whole of this, then 3 by the whole of this. So this will be, let's start with x. So this will be x times x squared, that will be x cubed minus x squared minus 20x. Then let's start with 3 now, okay, so plus 3 times x squared, that will be 3x squared minus 3x minus 60. Okay, so we need to rearrange, okay, or collect like terms. So this and this, okay, so we have x cubed, then minus x squared minus s squared plus 3x squared, that will be plus 2x squared. Also we have this and this, so this will be minus 20x minus 3x, so that will be minus 23x, then minus 60. So this will be the final answer. So let's write our final answer here. X cubed plus 2x squared minus 23x minus 60. So let's go to the next question. Question 11. The table shows 3 sequences. Complete the table. So we have to find the 6th term and the nth term for the 3 sequences. Okay, so let's start with the first one. So this one is minus 6. That is the term to term rule, minus 6. Okay, so this one will be 4 minus 6. That will be minus 2. Okay, so we can now form the nth term. So to form the nth term, so you already have the term to term rule, which is minus 6. That will be minus 6 multiplied by n. So let's test this, okay, if this is enough to be our nth term. So when n is equals to 1, so we're going to have minus 1 times 6. That will be minus 6. So what do we need to add to minus 6 to get 28? So that is 34. So that means our nth term will be minus 6n add 34. So let's take this again. Add 34. Okay, so the second sequence, so this is 1 over 6, 2 over 7. You can see difference of 1 at the numerator and difference of 1 at the denominator. Okay, so if you have the first one to be 1, okay, and you have the difference of 1 at the denominator, so that means it will be 6 will be equals to 1 plus 5. Okay, so if you want to generalize it now, so it will be n over n plus 5. So this will be the nth term, n over n plus 5. Okay, I'm yet to find the 6th term here. Okay, so if you follow the pattern, the next one here should be 5. After, as in the 5th one should be 5 over 10, which is simplified to 1 over 2. So the next one here will be 6 over 11. Okay, so sequence C, we have 1 over 4, 1 over 2, 1, 2, and 4. So if you look at this one here, so if you divide, I think you multiply by 2, okay? So if you multiply 1 over 4 by 2, you get 1 over 2. If you multiply 1 over 2 by 2, okay, so you get 1. If you multiply 1 by 2, you get 2. Multiply 2 by 2, you get 4. Multiply 4 by 2, so you get 8. So this will be 8 here. So now we need to find the nth term now. So since we already have 2, so this is not a linear sequence, unlike the first one. The first one, that is sequence A, is a linear sequence. So this sequence here is an exponential sequence or geometric sequence. So since the common ratio rather, okay, is multiplied by 2, so it will be 2 to the power of n. Okay, so for a linear sequence we do 2 times n, not 2 to the power of n. So since this is a
geometric sequence, which will be 2 to the power of n. So let's check if this is enough to be our nth term. Okay, so when n is equals to 1, you get 2 to the power of 1, but whereas we should get 1 over 4. So that means we need to multiply these 2 by something. Okay, so it will be 1 over 8, because when you multiply by 1 over 8, so this will give us 1 over 4. So that means the formula will be 2n to the power of 1 over 8. Okay, we can actually simplify that. So it will be equals to 2 to the power of n. Okay, multiplied by 1 over 2 to the power of 3, which is the same as 2 to the power of n times 2 to the power of negative 3, okay, which is the same as 2 to the power of n minus 3. So this is the formula. This is the nth term for sequence C, 2 to the power of n minus 3. So if you test this, it will give you each of the terms in the sequence. Okay, so let's go to the next question. That will be question. Okay, I think we should have question 12. So let's scroll down. Okay, good. So in this now, we are asked to find the value of k. So what you need to do is to rewrite this. So this is the same as 10 to the power of 400, okay, over 10 to the power of 220 multiplied by 10 to the power of 80, okay, then everything raised to the power of a half, okay, then equals to 10 to the power of k. Now we need to use this power, okay, to multiply. We need to open the bracket, okay, that is the power law. So we multiply each of the powers by a half. So that implies 10 to the power of 400 times 1 over 2, okay, so that will give us 200, okay, over 10 to the power of 220 times 1 over 2, that will give us 110, times 10 to the power of 80 times 1 over 2, that will be 40, okay, that will be 40 equals to 10 to the power of k, okay, so this is 200. Now we can do something here, okay, these two we can apply multiplication of indices. We have the same base, we pick the base and add the powers, so it implies 10 to the power of 200 over 10 to the power of 110 plus 40, okay, that will be 150, okay, then equals to 10 to the power of k, okay, so we can also apply division of indices. We have the same base, then we subtract the powers. We have 10 to the power of 200 minus 150, that will be equal to 10 to the power of k. So we have 10 to the power of 50 to be equal to 10 to the power of k. So this cancel this, and k is equal to 50. Okay, so we can go to the next question. That is question 13a. Line L has the equation y equals to this. Find the coordinates of the point where line L intersects the y-axis. Okay, so if we open this equation, we have y to be equal to 2x minus 2 times negative 10 and negative 5. That will be negative 10. Okay, so if you compare this equation with the general equation of a straight line, which is y equals mx plus c. So c is the intercept on y-axis, okay, so and by comparison, c equals negative 10. So the coordinate will be x equals to s equals 0 and y equals negative 10. So that will be the coordinates, okay, of the intercept on the y-axis. Part B, find the x coordinates of the point where line L intersects the line y equals 19. So in this now, we want to find the x coordinates of the point where the line L intersects the line y equals 19. So this is line L. Line L is y equals 2x minus 10, okay, and we have another equation which is y equals 19, okay, so where they intersect is where they meet, okay, so that means
2x minus 10 should be equal to 19. Then 2x equals 19 plus 10. Okay, 2x equals 29. Okay, so we need to divide both sides by 2. X equals 29 over 2, which is 14.5. So let's go to part C. Line P is perpendicular to line L. Okay, so if you have line L to be like this and line P is perpendicular, okay, so this will be line P, okay, and you can call this any point, okay. So line P passes through the point 2, 3, that is 2, 3 here. So find the equation of line P. Give your answer in the form y equals mx plus c. Okay, so we can take x1 to be equals to 2 and y1, okay, let's erase that, and y1 to be equal to 3. Okay, so we need to find the gradient of the line P. Okay, but from the equation of line L, we have y to be equal to 2x minus 10. Okay, 2x minus 10. Okay, so this is the gradient. It is 2 out of 1. Okay, now the gradient of line P, okay, is line P and line L are perpendicular. Okay, so that means the product of their gradient should be equal to -1. So if we take this one to be the gradient of line L, okay, so we can say the gradient of line L multiplied by the gradient of line P should be equal to -1. Okay, so since we need the gradient of line P, so we can divide both sides by the gradient of line L. Okay, so that will be divided by the gradient of line L is 2 over 1, so which will give us -1 over 2. That will be the gradient of line P. So using the general equation of a straight line, okay, of this form, the one that passes through a point, okay, it will be y minus y1 equals m into x minus x1. Okay, if you key in the values, we have y minus 3 equals the gradient now -1 over 2 into x minus 2. So we need to simplify this. We have y minus 3 and equals -1 over 2x, then plus, if you do this, it will give you 1. Okay, so if you rearrange, okay, that will be y equals -1 over 2x plus 1, then plus 1, then plus 3. Okay, so finally we have y equals -1 over 2x plus 4. So y equals -1 over 2x plus 4. Okay, so let's go to the next question. Question 14. Just invest $1,400 in an account. The account pays compound interest at a rate of R% per year. At the end of 4 years, the value of our investment is $1,523.15. Find the value of R. So we can write down the parameters here. P equals $1,400. Then the rate at which the interest is paid is R%. Okay, so which we can write as 0.01 R. Then the number of times interest is paid in a year is 1, n equals 1, t equals 4, and the amount equals $1,523.15. Okay, so let's using the formula. Okay, so that is the amount equals to the principal multiplied by 1 plus R over n. Okay, so let's write this 1 plus R over n, then to the power of n t. Okay, so if you key in the values, so the amount will be equals to 1523.15 equals 1,400 over 1 plus 0.01 R over 1 to the power of 1 times 4. So let's divide both sides by 1400. okay, 1400. So this will go, okay. And another thing we can do here is to, okay, let's write this as 1523.15 over 1400, then equals 1 plus 0.01 r to the power of 4. Okay, so this one is a whole, then we can multiply the powers. So this is raised to the power of 1, and we can multiply the powers by 1 over 4 because we want to make r the subject of the formula. Okay, so if we do so, so this will give us 1523.15 over 1400 to the power of 1 over 4. Okay, so equals 1 plus 0.01 r. So we need to bring this one here now. Okay, and this one we can write it to the fourth root. Okay, it will be this now. Okay, I think I can write 1523.15 over 1400. Then I can now write the root like this. So we put 4 here. Then minus 1 equals 0.01 r. So you can actually divide both sides, okay, by 0.01. So 0.01, then divide this by 0.01. So this will give you 2.13 to 3 significant figures. So r equals 2.13, okay, 2.13. So let's go to the next question, question 15. Okay, sorry, m is inversely proportional to the square root of t plus 2. M equals 0.5 when t equals 23. Find m when t equals 98. So this will give us m inversely proportional to the sum of this, to the square root of this. That will be square root of t plus 2. Okay, so this will give us m equals 1 over m equals k. Okay, I think I can write that. So m equals k, okay, times 1 over square root of t plus 2. Okay, good. Then you can now substitute the values. M equals 0.5 from here and t equals 23. So if we do that, this will give us 0.5 equals k over square root of 23 plus 2. Okay, 0.5 equals k over square root of 25. So 0.5 equals k over 5, and k equals 0.5 times 5. That would be 2.5. So the value of k equals 2.5. Okay, so that means we can rewrite this. Okay, we can write this equation, this particular one. It will be m equals 2.5 over square root of t plus 2. Okay, now I want to find m when t is equal to 98. So we just have to substitute there. So m equals 2.5 over square root of 98 plus 2. This equals 2.5 over square root of 100. This equals 2.5 over square root of 100 is 10. So our final answer equals 0.25. So that will be the final answer, 0.25. So let's go to the next question. That will be question 16. By shading the unwanted regions of the grid, draw and label the region R which satisfies these three inequalities. The first one is y less than 3. So y less than 3. So to get y less than 3, you need to draw y equals 3. So this is with a broken line. Okay, so it will be here. Let's draw a line like this. From here, draw this line.
Okay, good. But we need the unwanted by shading the unwanted area. So the wanted area is down. Okay, so the unwanted area will be up. Okay, so we can actually highlight that. So let's shade the unwanted area. So it will be this area, like this. So this is the unwanted area. Okay, just try to take the edges first. Okay, so I can take this now. So you can take your time to shade it properly. So you have to shade carefully. Sorry. Okay, so you take your time and shade carefully. Okay, so this is the unwanted area for y less than 3. Okay, so the second one is x less than or equals 2. Since there's an equality sign here, so we need to make use of a thick line. Okay, so this is x equals 2. You can just take it from here like this. Okay, let's take it again. So this is x equals 2. Okay, so the unwanted area, so x is less than or equals to 2. So this side will be the unwanted area from here like this. Will be unwanted area. So let's take it gently. Okay. So this will be unwanted area. So let's try and shade it on time. Okay, so I think this is cool. Okay, so that is the unwanted area for x less than or equals to 2. Then the last one is this, y is less than x plus 3. So we need to do y equals x plus 3. Okay, then we cannot get y less than x plus 3 from it. Okay, so if you compare this with the general equation of a straight line, this is mx plus c. So the intercept on x-axis, on y-axis rather, is 3. So there's a point here, and the gradient is 1 over 1. Okay, that is you jump up once and you run forward once. So this is 1, then 1 here. There will be another point here. 1, 1. There's another point here. 1, 1. There's another point here. Okay, so it will go like this. So these are all the points like this. Okay, fine. So this one we don't have equal to. Okay, so we need to use a broken line as well. So let's join these lines together, these points together from here. We draw the line here. Okay, like this, up to this spot here. Okay, now we need to get the side which is less than, where y is less than x plus 3. Okay, so in case you're always somehow confused with this, okay, what you need to do is very simple. So you can just take we have the upper part here, we have the lower side here. You can just take a point. Let's take a point from here, okay, to actually test the wanted area, to actually get the wanted area or the unwanted area. So if I pick this point here now, for instance, let's say this point. Okay, so I want to know if this side is my wanted area or unwanted area. So here x equals -2 and y equals +2. So now let's see what will be would this be true or false? So y, which is 2 now, is less than
x, which is minus 2 plus 3. So this is 2 less than 1. Okay, so this is false. So 2 is not less than 1. So that means this side is the unwanted area. Okay, so that means this side is the wanted area for this line. So I can easily shade the unwanted side now. So it's going to be this side now. So let's shade this gently. Okay, like this. Okay. So let's complete this. Okay, I think we are cool. Okay, now for this now, so the region R now will be this. This is region R, so we can just write R here. So R will be this unshaded region, so we can put our R there. Okay, so that is the end of that question. So let's go to the next question. Okay, let me check. Did I skip any question? Oh, good. Question 17. In the Venn diagram, shade the region this. So to shade this region A union B intersection C complement. Okay, so where is C complement? Okay, so C complement. Okay, there are many ways you can use to shade this, but one of the ways I do is that you need to exclude this C, the whole of C. So actually, C complement means all the available regions, okay, outside C. So it will be this outside the 3 circles, and then part of circles A and B, but not C. So that means this circle C is a no-go area, so we don't have to touch it now. So we need A union B. So to combine A union B, okay, that's the part of A union B which is not in C. That is what we want to shade. So that means we need this side from here now. Okay, sorry. So let's take this from here like this. We need the whole of the combination of A and B, which is not part of C. Okay, so that is what we need. So I will take it like this. Okay, I also take this one like this. Okay, so I can now complete it by shading this. Okay, so I can complete it by shading this. Okay, so I think we are a little bit cool here. So this is the area you have to shade. So I think that is the end of that question. So let's go to the next question. That will be question 18. The diagram shows a solid cuboid with sides of length 4.5 centimeters, 8 centimeters, and 13.2 centimeters. So A, calculate the volume of the cuboid. So the volume, okay, equals, so the volume equals the length times the width times the height, okay? So that's gonna be 13.2 multiplied by 14.5, okay? Then multiplied by 8, okay? So if you input this into a calculator, you should get 475.2. So part B, calculate the total surface area of the cuboid, okay? So the total surface area of the cuboid gonna be 2 times area of each face, or the addition of area of the 6 faces. But we have opposite faces, okay, to be equal. So we can actually use 2 for them. So we can do 2 into now. So what you have to do is just to you can use 2 for everything. Okay, then we take the area of this and this. Okay, so area of this face, area of the base, and area of this side.
So we multiply by 2, and that will be the area of the 6. So area of the base, so multiply by area of the side, okay, and we have area of the front, okay. So that will give us the area, and when you multiply that by 2, it will give us area of the 6 faces, okay. So what we can do now is to do 13.2, okay, 2 into 13.2, okay, times 4.5. So this will give us area of the base, and we're multiplying by 2. That means this will give us area of the base and area of the top, okay. Then plus another one we can do here is to write 13.2 multiplied by 8, okay. So this will give us area of the front side, okay. So and multiply by 2 will give us area of the front and the back side together. So we have 4 faces rather, okay. So plus then we need to do 4.5 multiplied by 8, okay. So this will give us area of the side, okay. Since we are multiplying by 2, it will be area of the 2 sides, okay. So this will give us area of the base and the top. This will give us area of the front and the back, and this will give us area of the two faces or the 2 sides, okay. So if you input this into a calculator directly, you should get 402, okay, 402. So part C here, calculate the angle between AB and the horizontal base of the cuboid, okay. So what we need to do is here now we need to draw a line, okay. Sorry, let's change that. So let's draw a line to the base like this from A, okay. Let's take that again to this place, okay. So that is the base. Then the angle between AB and the horizontal base, so between AB now, say AB will be this, like this, okay. So now we can call this one T. So this is the angle we need, okay. So we have to make use of this triangle ABT. So we can call this angle theta. So we already know BT to be 8, so we need to find AT. So we can get AT from this base. We can use AT squared, okay. We can do that here. AT squared equals to the square root of 13.2 squared plus 4.5 squared, okay. Then if we do that, we know from triangle ABT, so tan theta equals 8 over AT. Sorry, this one is not 80 squared, it is 80, okay. So and from here we can get theta to be equals to tan inverse, okay. If you take tan inverse of both sides, so theta will be equals to tan inverse of 8 over 80. So 80 equals square root of 13.2 squared plus 4.5 squared. So you can input this into your calculator, and the value of theta will be 29.8. So you don't need to waste time since you have your calculator. So let's go to the next question. That will be question 19. So the table shows some information about the height of 200 plants, okay. So draw a cumulative frequency diagram to show this information, okay. So what you need to do is we need the value, okay. So we need to get the value of each line on the y-axis, okay. And if you see from here now, this is it is 4, okay, because 10 lines give 40 units, okay. So a line will be 4 units, okay. So let's go to the first one here. When the height is 30, the cumulative frequency is 6. So let's see. So when the height is 30, so we have the cumulative frequency to be equal to 6. So this will be 4, okay. Then 6 will be the middle here, okay. Then the next one is when the height is 40, okay, we have 40 against 42. So 40 against 42. So this is 40, okay, so 42 will be the middle here, okay. Then the next one will be 50 against 76, 50 against 76. So this will be 60 here, so we need 76. So this is 64, 68, 72, okay, and 76, okay, will be here, okay, this particular one, okay. But you can actually go to 76, because after 76 the next one is 80, so it's just a line, but you can always count, okay, if you are confused. Then the next one, it is 60 against 170, okay, 60 against 170. So we have to go up a little bit. This is 60 here against 170, so this is 160. Then this is 180, so we need the half of it here, which is here, okay. This is 1, 2, so it will be here. That will be the middle of this line, okay, because this place is 180, so the half will be 170, okay. Then the next one is 190, 70 against 190, so this is 70 against 190, so this is 180, this is 200, so the middle will be 190 here. And the last one is 80 against 200, 80 against 200 to be this spot, okay. So you need to take your French curve, okay, and join these points together like this, okay. So I'm going to use a freehand sketch, okay. So this is the freehand sketch of the point. So let's go to the next question. Part B, find an estimate of the 75th percentile, okay. So the 75th percentile will be equal to 75 over 100 multiplied by 200. So that will be the position, which is 150. So the 75th, an estimate for the 75th percentile will be at this spot here. So we need to draw line at 150. So this is 160. So this is 120. So this will be 140. So 150 will be the middle, which is here. So we can just draw a line from here like this, very close to this, okay. So if you trace it down here, is around here about 59, okay. So I can say that it will be 59. That will be an estimate, 59 centimeter. That will be the height, okay. So let's go to the next question. That should be question 20, okay. Stephen has 2 bags, A and B, each containing red sweets and yellow sweets only. He picks 2 sweets at random, one from bag A and the other from bag B. The probability that Stephen picks a red sweet from bag A is 3 out of 5. The probability that Stephen picks a red sweet from bag A and a red sweet from bag B is 2 over 15. A, find the probability that Stephen picks a red sweet from bag B. Okay, so what we need to do here, we can just draw a probability tree diagram. So from here, so we have for A, so this will be 3, we have red and we have yellow. So this is giving us 3 over 5. Okay, so automatically yellow will be 2 out of 5. Okay, therefore the bag B, we also have red and yellow. Okay, but we are told that we know that the probability of let's say, we're told that the probability that Stephen picks a red sweet from bag A, so probability of a red sweet from bag A and a red sweet from bag B is 2 over 15. So we know that the probability of red switch from bag A is 3 out of 5. So 3 out of 5 multiplied by the probability of red switch in bag B. So you can say the probability of red switch from bag B like this. So the product should be equal to 2 over 15. Okay, so if you multiply both sides by 5 over 3, okay, times 5 over 3, so this will go, okay, this will cancel this, so we're left with this. So the probability of red from the probability of selecting red switch from bag B will be equal to 2 over 9 if you simplify this. Okay, 5 here 1, 5 here 3, you have 2 over 9, so you can put 2 over 9 here. So automatically the probability of yellow from bag B will be 7 over 9. So find the probability that Stephen picks a red switch from bag B. So this is 2 over 9. Then part B, find the probability that Stephen picks a yellow switch from bag A and a yellow switch from bag B. So that will be the probability of yellow from bag A times yellow from bag B. So this will be equal to 2 over 5 multiplied by 7 over 9. That is equal to 14 over 45. So that will be our answer. So 14 over 45. Okay. So let's write this. So that is 14 over 45. Okay, so let's go to the next question. That will be question 21. Question 21. The diagram shows an equilateral triangle ABC with all sides of length 12 centimeters. AMP is a sector of a circle center A. N lies on AC such that AN ratio MC equals 2 ratio 1. P lies on AB such that AP ratio PB equals 2 ratio 1. Calculate the area of the shaded region. Okay, so the area of the shaded region will be area of the whole triangle, okay, minus the area of this sector. Okay, but since this is an equilateral triangle, okay, so we know that each angle will be 60 degrees. Okay, so this is easy for us. Okay, and we know that the ratio, this is 2 to 1, this is 2 to 1. Okay, so and we know that the value of a length of a side is 12 centimeters. So we can actually find this. Okay, so since the total ratio is 3, so 1 over 3 times 12 is what? 4. So that means this will be 4 centimeters, this will be 8 centimeters. Okay, so by using the ratios, so this will be 4 centimeters and this will be 8 centimeters. So we cannot use this to calculate everything we need. Okay, so let's go down. So we need to calculate the area of a sector. The area of a sector equals theta over 360 times pi r squared. Okay, so the radius of the sector is 8 centimeters. Okay, and the angle is 60 degrees. So I think I can scroll down here. So area of the sector denoted by this. Okay, or I can write this. Okay, so equals theta, which is 60 over 360 times pi, which is 3.142 times the radius, which is 8, then squared, pi r squared. Okay, so this gives 33.5147 centimeters squared. Okay, then we need to calculate the area of the equilateral triangle. Since we have 3 sides, so we can use Heron's formula. Okay, so using Heron's formula, okay, for finding area of a triangle when the 3 sides are given. So we have the area of the triangle to be equal to the square root of s into s minus a into s minus b, okay, into s minus c. Okay, so where s equals a plus b plus c over 2, that's the addition of the 3 sides divided by 2. Okay, so each side is 12, so you have 3 times 12, or 12 plus 12 plus 12. Okay, 12 plus 12 plus 12. So I'll do 3 into 12. Okay, since I don't want to repeat myself, over 2. Okay, so 2 here 1, 2 in 12, 6. So 3 times 6, so that will be 18. So x equals to this, s equals to that, s equals 18 centimeters. Okay, then I can now do this. So the area now, area of the triangle equals the square root of s, which is 18, into 18 minus a, that will be 18 minus 12. Okay, that will be 6 into 6 into 6, because all the sides are equal. So each of these gives 6. Okay, so you can input this into your calculator and you get 3538. So the area of the shaded portion now will be area of the triangle, okay, which is 62.3538 minus the area of the sector, which is 3.5147. So this should be approximately 28.8. Okay, so that will be the area of the shaded portion. Question 22. A metal cube has mass 14.2 grams, correct to 1 decimal place. Find the lower bound of the mass of the cube. Okay, so since it is correct to 1 decimal place, so we count in tenths. So we have 14.2. The next one will be 14.3. The one before will be 14.1. So the lower bound is the made of 14.1 and 14.2. So this is straightforward. Okay, so this will be 14.15 grams. So you can add the two numbers together and divide by 2. Okay, so that is pretty easy. So the side length of the cube is 1.3 centimeters, correct to 1 decimal place. Calculate the upper bound of the density of the metal. So the formula for density has been given to be mass over volume. Okay, so now we need the formula for the upper bound of the density. Okay, so the upper bound of this density, so let's say the upper bound of the density equals the upper bound of the mass, okay, divided by the lower bound of the volume. So this is what we need to do. Okay, but we need to calculate the upper bound of the mass. Okay, so from here in part A, we already have this, so we can easily get the upper bound of the mass. So the upper bound of the mass, it will be between 14.2 and 14.3. Okay, so which is 14.25. So 14.25. So that means the upper bound of the mass will be 14.25. So we need the lower bound of the volume. So firstly, we need to calculate the volume. The lower bound of the volume will be equals to lower bound of the length, okay, cube. Okay, that will be the lower bound of the volume. So the volume is given as the length of the cube is 1.3 centimeters. Okay, so the lower bound of the volume will be the lower bound of the length of the cube, okay, to the power of 3, or you can multiply it by itself 3 times. Okay, so since it is correct to 1 decimal place, so the lower bound of the length, okay, lower bound of the length is, okay, we have 1.3, so the one before will be 1.2, so the lower bound will be 1.25. Okay, so lower bound of the volume, okay, will be equal to 1.25 cube. Okay, so this will be equal to 1.9531. So we can now complete this. So 1.9531. So this is pretty easy. Then this will give us 7.296. Okay, so this will be the answer. So let's scroll down. So 7.296. Okay, so let's go to the next question. That will be question 23. The diagram shows a frustum made by removing a small cone from a large cone. The height of the small cone is 7.5 centimeters. The height of the frustum is 4.5 centimeters. The radius of the large cone is 4.2 centimeters. Work out the volume of the frustum. So the volume of the frustum, okay, the volume of the frustum equals to volume of the bigger cone minus volume of the smaller cone. Okay, so that's what we need to do. So the volume of a cone is base area times height divided by 3, or volume of a cylinder divided by 3. So now the volume of the bigger cone, let's calculate the volume of the bigger cone. So the volume of the bigger cone equals pi r, that's the radius of the bigger cone, let's note that is squared, times height of the bigger cone, okay, divided by 3. So what is the radius of the bigger cone? So we know that the radius of the bigger cone is 4.2, okay. So we need to find the height of the bigger cone. So the height of the bigger cone, okay, so the height of the bigger cone, so equals the height of the frustum plus the height of the smaller cone. So that would be 4.5 plus 7.5. So this equals 12 centimeters, okay. And we know that the radius of the bigger cone is given as 4.2 centimeters. Fine. So now I can now do the work in here. Okay, so the volume of the bigger cone will be pi 3.142 multiplied by the radius. So we found the radius is given as 4.2, okay, 4.2 squared multiplied by the height, which we found to be 12, okay, centimeters from here. Then divided by 3. So if you input this into a calculator, you should get 221.6995 centimeter, okay, cube. Okay, so we need to get the volume of the smaller cone, okay. So the volume of the smaller cone, so equals pi r, radius of the smaller cone squared, times the height of the smaller cone, okay, divided by 3 as well, okay. But we don't know the radius of the smaller cone. So here, from here to here is the radius of the smaller cone. So we can use the concept of what? Of similarity, okay, because the smaller cone and the bigger cone are similar shapes, okay. So we can use the ratio of the corresponding sides. So we can say the radius of the bigger cone over, or we can say the ratio of the radius is equal to the ratio of the height. So that is radius of the bigger cone over radius of the smaller cone, so equals the height of the bigger cone over height of the smaller cone. So that is what I'm going to use to get the radius of the smaller cone. So let's write radius of the bigger cone over radius of the smaller cone equals height of the bigger cone over height of the smaller cone. So let's key in the values. This will be 4.2 over radius of the smaller cone we want to get equals to height of the bigger cone, that is 12, over height of the smaller cone, 7.5. If we cross multiply and make our radius of the smaller cone the subject of the formula, so this will give you 4.2 times 7.5 divided by 12, okay, and eventually this gives 2.625, okay. Now, so we have the radius and the height of the smaller cone equals 7.5. So we cannot get the, let's scroll up, we cannot get the volume now. The volume of the smaller cone, so equals 3.142 times 2.625 squared multiplied by 7.5 divided by 3. So which is equal to 54.1259. So the volume of the frustum now equals the volume of the bigger cone, 221.6995, minus volume of the smaller cone, 54.1259. 1259. So the volume of the frustum finally is 168, correct to 3 significant figures. Okay, so let's go to the next question. Question 24. The histogram shows information about the distance some people travel to work. Okay, so use the histogram to complete the table. Okay, so from 0 to 0 is less than d is less than or equals to 5. So that is from here to here. Okay, we want to get this. So we are given the frequency density as well as the distance covered. We need the number of people, so we need the frequency. But we know that there is a formula, okay, that connects the frequency and frequency density together. So that will be frequency density equals frequency over the class size. So from here, frequency equals frequency density multiplied by the class size. So this is what we are going to use, okay? So for the first one, so what is the frequency density? Okay, so let's see. The frequency density for the first bar, okay, from here to here, the frequency density is 2.8. Okay, what is the class size? The class size is 5 minus 0, which is 5. So that means this will give us 2.8 times 5, okay, which is equal to 14. Okay, so from the next one will be from 5 to 20. Okay, but we don't have from 5 to 20 directly. So four of us do, okay, let me erase this. Four of us do 5 to 10, then we'll now do 10 to 20, then we'll add the two together. Okay, so for 5 to 10, so it will be the density is frequency density is 3.4, okay, times the class size, which is 5. Okay, so it will be 3.4 times 5, okay, that is the first part, plus the second part, which is the frequency density is 2, that is from here to here, so it is 2 times 10, okay, plus 2 times 10. So if you do this, you should get 17 plus 20, that is 37. So the third one is from 20 to 50. So we don't have from 20 to 50, but we have from 20 to 30, okay, that is from here to here, and from 30 to 50. So we're going to do them bit by bit and add them together. So from 20 to 30, so the frequency density is 1.6 multiplied by the class size, that is 10. Then from 30 to 50, the frequency density is 0.4 multiplied by the class size, that is 20. Okay, so I'm going to write 1.6 multiplied by 10, okay, add 0.4 multiplied by 20, and the final answer will be, so this will give us 16, this will give us 8, okay, so and everything will be 24. As simple as that. Part B, the people who travel a distance greater than 35 kilometers to work have a car allowance. Calculate an estimate of the number of these people who have a car allowance. Okay, so more than 35, so you need from here. Okay, so from here, more than 35, it will be from here like this to this. Okay, so that is what we need. So it will be 50 minus 35, that will be class size, which is 15. Okay, and the height is this 0.4. okay, is 0.4. That's the height. Okay, so what we just have to do is 0.4, that is the frequency density, multiplied by the class size, which is 15. So this will give us 6. Okay, so let's go to the next question. Question 25a. Sketch the graph of y equals sine x for this given interval. Okay, so we know that sine 0 equals 0, so we're going to start from here. then at 90 it will reach the peak here. Okay, so we can just do something like this. Okay, then it will come at 180 degrees. Okay, it will come back to 0, so this will be 180 degrees. Then after another 90 degrees it will come to this -1. Okay, then after another 90 degrees, okay, it will come back to this. So this is what you have here. Okay, so part B, solve the equation 2 plus 5 sin x equals 1. Okay, from here we can subtract 2 from both sides, so this will leave us with 5 sin x equals 1 minus 2 minus 1, then sin x equals -1 over 5. So this is what we get. Okay, now okay, we can take sine inverse of both sides, so x equals sine inverse of -1 over 5. So finally x equals 11 minus 11 point let's say 5 thereabout, or 5370. Okay, so now we need to find so this is a negative angle, so which is outside the given interval, so we need to find where sine is negative. Okay, so let's draw the 4 quadrants, so this and this. Okay, so we have the negative angle to be like this here. Okay, so that means it's moving towards this direction. Normally it should be like this. Okay, so since it is negative, so 11.5 will be here. Okay, so all students take calculus. Okay, so sine is negative here, so we're gonna get this angle, and sine is also negative here, so we're gonna get this angle here. So this angle will also be equals to 11.5. So the first angle will be from here to here, that's first value, so that will be 180 add 11.5, that is the total angle. So this one will give us our first answer, that will be 191.5 degrees. Okay, so the second one will be from it should be from here. Okay, the first one is from here to here. Okay, so the second one will be from here. Okay, so back to this place, so that will be 360 degrees minus 11.5, so that will be 348, okay, 0.5 degrees. So that will be the solution. Okay, so this is the last part of the question 26. So it's a vector question. The diagram shows a quadrilateral OXPY with diagonals meeting at C. OX equals to 3a and OY equals OX equals 3a and OY equals 12b. Find XY in terms of A and B. Okay, so XY from here, this is XY. So let's write here XY equals XO add OY. Okay, so this equals XO is opposite, is moving in opposite direction to OX. That will be minus 3a, then plus OY. OY is in this direction, that is 12b. So you can write your answer as that, or you can factor out 3. So I'll leave my answer as this, minus 3a add 12b. Okay, so part B, xt ratio ty is 1 to 2 and yp equals 5a minus 2b. Okay, so we can start from this given ratio, xt ratio ty. Okay, so the total ratio will be 3. Okay, total ratio will be 3 if you add them together. So we can actually find xy. So xy equals Okay, we already found xy to be equal to this, so let's write xy equals minus 3a plus 12b. So we can start from the given ratio. Since xt ratio ty is giving us 1 to 2, so we can actually find xt. Okay, we can actually find xt, and we can actually find ty. Okay, so the total ratio will be 3, so that means xt equals 1 over 3 of the whole line, which is xy. Okay, so the whole line here is xy. Okay, so that is what we're going to do now. So it will be minus 3a plus 12b. Okay, so xt, so we can put the direction here. Okay, so equals, if we expand this, we get minus a, okay, plus 4b, so that will be xt. So similarly, we can get ty, so ty equals 2 over 3 into minus 3a plus 12b. So if you expand that, you get ty to be equal to minus 2a plus 8b. Okay, so from this now, we can actually find OT. We need to find OT, we need to find TP. Okay, so once we get OT and TP, then we can get the ratio. So from here, you see that OT equals OX plus XT. Okay, like this and like this, back to this. So let's write that. So we can say that we can demarcate this one. No troubles. So let's write OT equals OX plus XT. So this is equal to 3a. Okay, then it's moving in opposite direction of xt. Okay, so no, I think okay, it's the same direction. So it's moving xt. What is xt? Xt is minus a plus 4b. So it will be minus a plus 4b. So this will be 2a plus 4b. So we can factor out 2. It will be 2 into a plus 2b. Okay, so this is one answer here for OT. So we need to find TP now. TP, okay, will be equal to, let's go, TP. Let's see. So TP will be equal to TY plus YP. Okay, so they are moving in the same direction. So let's write TP equals TY add YP, so which is equal to TY is this minus 2a plus 8b minus 2a plus 8b, then plus YP, so that is giving us 5a minus 2b. Okay, 5a minus 2b. So we can simplify this. It will give us 3a plus 6b. So if you factor out 3, it will be 3 into a plus 2b. Okay, so this is the second one. So the ratio will now be 2 into a plus 2b over 3 into a plus 2b. So this will cancel this. We have 2 ratio 3. Okay, so this will be the final answer. So this is the end of my solution to the Cambridge IGCSE Mathematics paper 4.3 written in June 2025. So in the next video, I'll be solving the papers 2.1, 2.2 and 2.3 respectively. Until then, have your fingers crossed.